All right, we are here looking at the results of our antibiotic susceptibility test using the Kirby-Bauer method. So we have 3 plates that we inoculated with different broths. All of these are Mueller-Hinton plates, the medium that we use for this exercise. And we applied to each of the plates 2 different antibiotic discs, cefamexine and carbacillin. So you can see on these plates, some are easier to see than others, but on the left-hand side we have E. coli growing, and you can see the zone of inhibition around the antibiotic disc. So this zone of inhibition is where the microorganism was unable to grow due to its susceptibility to the different antibiotics. We can see that here for the Pseudomonas fragi. It's a little more difficult to see that zone of inhibition. You can see it a little easier on the right with our carbacillin. And then for our Staphylococcus epidermidis, we can also see that zone of inhibition. So to interpret the results of this experiment, we use this chart, this interpretation chart, that allows us to measure the zone of inhibition from one side of the zone to the other. So this shows you're going to have a zone of inhibition around your antibiotic disc, and we're going to measure from each side the diameter of this zone of inhibition, and then compare it to the different values for resistance or susceptibility. All right, so let's do this. We have our E. coli plate. We are using a centimeter scaled ruler, and we can see that this is just at maybe 1.8 centimeters for E. coli with carbacillin. We can see, however, that the units for this table are in millimeters. So 1.8 millimeters is 1.8 centimeters is 18 millimeters. And we are going to make sure that we are testing using the interpretation for gram-negative organisms for carbacillin. So as you can see, this subscript 4 notes when testing gram-negative organisms, and so here for carbacillin with our subscript 4, we know to use this line for our interpretation. And we see that if it has a zone of inhibition of 19 millimeters or less, as does our E. coli result for carbacillin is 18 millimeters, so we would classify E. coli as resistant to the antibiotic carbacillin. And so then we go back and we measure for cefexamine, and we see pretty similar zone of inhibition. We'll call that 18 as well. So 18 millimeters or 1.8 centimeters. For cefexamine, that same measurement of 18 millimeters, in this case, it indicates that E. coli is intermediately susceptible to cefexamine. Next, for Pseudomonas fragi, we can see our zone of inhibition is quite a bit smaller. We're going to call this 1.2 centimeters or 12 millimeters. And that's for the cefexamine. So again, 12 millimeters for cefexamine is less than 15. So Pseudomonas fragi is resistant to cefexamine, as was our E. coli. And then when we measure for carbacillin, again we have a it's a little bit difficult to see, but I'm going to also call this 1.8 centimeters or 18 millimeters. But we can see that we have the subscript 3 when we're testing Pseudomonas aeruginosa, but we are going to be using that same interpretation for our Pseudomonas fragi. So for carbacillin, we have our subscript 3, and as we go over, we can see that our measurement of 18 is greater than the measurement of 17, the minimum value for which susceptibility is indicated for Pseudomonas for carbacillin. So Pseudomonas is susceptible to carbacillin. It has a measurement of a zone of inhibition of 18 millimeters, which is greater than 17, so it is susceptible. Finally, we have our Staphylococcus plate. For Staphylococcus, when we measure the zone of inhibition, looks like 1.5 centimeters, 15 millimeters, and that's for carbacillin. For carbacillin, 1.5 millimeters is intermediate. So Staphylococcus has an intermediate resistance to carbacillin. And finally, for cefiximine, I'm going to call this 21 millimeters, 2.1 centimeters. So for cefiximine, so it is also susceptible to cefiximine. So Staphylococcus epidermidis is susceptible to both cefiximine and carbacillin. And so that is how we do the Kirby-Bauer method of testing antibiotic susceptibility using a Mueller-Hinton plate, antibiotic discs, and then a broth culture to create a lawn of growth on the surface of the Mueller-Hinton plate that gets incubated with the antibiotic discs, and after 48 hours we are able to measure the zones of inhibition for our different organisms and for each of the antibiotics we tested. Then we use this table to allow us to interpret what the significance is of those zones of inhibition, whether they indicate resistance, susceptibility, or an intermediate susceptibility to the different antibiotics.